Complete the table using ticks and crosses to describe the properties of liquids, gases, liquids, and solids. So I'm not going to put the cross just because it's a little bit clear, but if I leave it blank, that means you need to put a cross over there. All right, particles that are touching, so that's true for liquids are touching, solids are touching, particles have random movement, so liquids are randomly moving, gases are randomly moving, particles are regularly arranged. That's only true for solids. Pretty easy, I think. All right, moving on. Substances can change their state. Boiling and evaporation are two ways in which liquid changes into a gas. Describe two differences between boiling and evaporation. Well, boiling happens at the same temperature. At a specific temperature. And evaporation will happen over a range of temperatures, but that's the opposite of the first statement, so I won't repeat myself. So, well, you can see bubbling. Whereas in evaporation, it can just evaporate without you seeing bubbling. Name the change of state when a gas becomes a liquid. That is condensation. A solid becomes a gas. That is sublimation. A substance boils at temperature X and melts at temperature Y. Complete the graph to show the change in temperature over time as the substance cools from temperature A to temperature B. So A, it's a gas right now, it's cooling, temperature is falling, and now the gas is turning into a liquid. And the until it's flat because the change of state is taking place. And once that's done, it's gonna fall even more so. So let me make a dotted line just to highlight it. Not too shabby. Okay, and it'll fall kind of in a straight line. Let's see if we can make a straight line like that. Go flat for a bit and continue falling. Kind of like that. Yeah, pretty straightforward. The reason this is happening, of course, is over here the gas is changing state to a liquid, so that, and the liquid now is changing state to a solid. Moving on, Part D. Name the process when a solid substance mixes with a solvent to form a solution. Dissolving? Really, I can't believe that's a question. And people say chemistry is hard. Dissolving. Name the type of reaction when two solutions react to form an insoluble substance. Two solutions that are soluble, or like two things that are soluble, or two solutions to form insoluble. I wonder what that could be. It's precipitation. Some acids completely dissolve in water to form ions. State the term applied to acids that completely dissociate in water. Dissociate, or in other words, ionize. Sounds like a definition for strong acids. So they're talking about strong acids. Okay, Complete the equation to show the complete dissociation of sulfuric acid in water. So sulfuric acid will just ionize. It ionizes to form H plus ions. There are two of them and one sulfate ion. And what's the charge? A lot of people are confused with the charge on the sulfate ion. Well, I'm not too sure why it's so hard. Well, it's H2SO4. Now, let's say you know that the hydrogen is going away. I mean, you should know enough acid and base to know that this is going to go bye-bye, right? It's going to go. So how do you find out the charge on the sulfate ion? Either you remember it, or you can actually work it out. So sulfate has some charge, right? Let's call it X. The entire thing is acting as one ion, by the way. If you don't know that, but it is acting as one ion, so it has one charge. And what is the charge coming from the hydrogen? Well, each hydrogen has plus charge, so the total charge coming from the two hydrogens is plus 2. Well, whatever the charge on the X is over here, it needs to balance the plus 2. Well, what number can balance a positive 2 charge? Shouldn't this be minus 2? Right? X equals to minus 2, positive 2 and minus 2, positive 2 and minus 2 will cancel out. The overall charge will be 0. This does not have a, this thing doesn't have an overall charge because there's no charge on it. So that's why I'm doing this math. I hope this made sense. And if it did, charge on the sulfate ion is 2 minus. All right, doesn't look like we have to show state symbols, but if you had to, it would be aqueous. State the color of methyl orange in sulfuric acid. Wow, this is this is difficult for me because I can't remember these things, but it is red in an acid. All right, let us move on. Let's move on. Part B, balance this equation out. Oh no, we don't have to balance it out. The equation for the reaction between powdered zinc and carbonate and dilute nitric acid is shown. Complete the equation by adding state symbols. Carbonate is going to be a solid, sulfuric nitric acid, aqueous. You have to put brackets in there. I'm just being a little lazy. To form zinc nitrate, all nitrates are soluble aside from, I think all nitrates are soluble. There is one nitrate, I think. Water is a liquid. Gas. Complete the equation by adding state symbols. Okay, student found that 2.5 grams of zinc carbonate required 20 centimeter cube of dilute nitric acid to react completely. Calculate the concentration of nitric acid. Well, calculate the mass of 1 mole of zinc carbonate. Over here, 1 mole of zinc carbonate. They're essentially asking us for the MR, which is going to be, I think it's just 125. It's an easy calculation, so I'm doing it off screen. 125. Moving on with our lives. Calculate the number of moles of zinc carbonate that reacted. So zinc carbonate was how many grams? It was 2.5 grams, so we know we'll use the mass over MR equation because we have the mass. 2.5 divided by 125. This is going to come out to 0.02 moles. Determine the number of moles of HNO3 reacting. Now, the ratio between zinc carbonate and the zinc carbonate to HNO3 was 1 to 2. So this should be 0.04. Pretty easy, I think. All right, calculate the concentration of HNO3. This was in 20 centimeter cube. So what will be the volume in 1 decimeter cube? So hence that is also the concentration. So concentration is moles, which is 0.04 divided by the total volume, which is 0.02. I don't even need a calculator. It's 2 moles. Let me remove the dot over there. That might confuse people. 2 mole per decimeter cube. Even though the dot doesn't really matter. It just means it could have been 2.0. That's also fine. But let's just remove that. Now, as a teacher, I feel like it's my duty to tell everyone, as easy as this table looks, people just get it wrong. For one thing, the mass of the proton and the neutron is the same. I think no one has trouble with that, 1 and 1. And a lot of people just write down the relative charge for a proton as positive and for the electron negative. Well, it's actually positive 1 and negative 1. And for neutron, they'll just put a dash or not applicable, like something like that. And that's wrong. That's going to not get you any marks. It has to be 0. With that said, let's move on. The table shows the number of protons, neutrons, and electrons. This is pretty easy. Okay, number of protons is 16. Oops. Let's get a different color. 16, 19, 16, 19. Number of neutrons is also 16. Oh my god. 16. 39 minus 19 is 20. I'm not too wrong, yeah. 39 it should have 16 electrons, sulfur, because this is 16, but it has no charge, so it has to be 16 as well. This should be 19 as well, but it has a charge, so 1 less. That's 18. Over here, they're telling us there's a proton number of 35. So looking at the periodic table, what's 35? Okay, bromine. Now bromine, now you shouldn't copy the values from the periodic table. Right now it's bromine 35. So look at what's written over here. The proton numbers are at the bottom. By the way, fun fact, how do you know the proton number is this number or this number? Well, it's either the proton number or the nucleon number, which is the sum of the proton and the neutron number. These two values are the same. The smaller one is the proton number. I think that's kind of simple. Anyway, this is bromine. Let's change the color. Bromine. Now it's bromine 35. Well, it has to be 35. It's not bromine 35. 35 plus 44 is 39. 79. It's bromine 79. You identify the isotope with the mass number. And does it have a charge? Well, it should have a charge because it has 1 less electron. Sorry, 1 more electron actually. So negative is fine. I think we're happy leaving it like that. 1 extra electron. Yeah. All right. Let's move on. This is easy. Breaking of bonds. And as, what is it? Why the reaction is exothermic. So if it's exothermic, this is because the bond formation energy is larger and reaction will be exothermic. If bond formation energy simplicans is larger than bond breaking. Easy. We shall move on. Complete the energy level for this reaction. All right, it's exothermic. So, well, it's exothermic, so could be better. Something like that. Maybe not as sharp. I know it's exo because energy is going down. It's releasing energy. That'll be change. I haven't read the question yet, but I'm sure they're asking me to highlight these. E, E, A, and what were my products? Products were COCl2. COCl2, is it aqueous? No, gaseous. Yeah, because the other two are gaseous. It makes sense. Why does it make sense? Because it's a reversible reaction. They're not really changing states too much. Okay. The product of the reaction, arrow representing the energy change, arrow representing the activation energy. What people normally do is make a two-side pointed arrow, like, well, it's one thing to reverse it, but if they make a reverse arrow or like a double-sided arrow, or over here, that's wrong. Don't do that. Okay? Okay, let's move on. State why a catalyst is used because it lowers the activation energy. Activation energy of the reaction. Describe and explain the effect, if any, on the position of the equilibrium when the pressure is increased. If you increase the pressure, there are 2 moles on the left-hand side of the equation, because it's 1 chlorine and 1 carbon monoxide, and 1 COCl2. So there are more moles on the left-hand side. Increasing the pressure will favor the side using more of COCl2. Alright, the temperature is increased, so the forward is exothermic, right? So increasing the temperature favors the endothermic reaction. Endothermic reaction. Equilibrium will shift. Will shift. The backward reaction is endothermic to the left-hand side, and describe and explain the effect. I don't have to comment. I guess this part was also useless. Right-hand side or left-hand side, that's all they care about. So let's move on. Alright, the reaction between chlorine and carbon monoxide can be represented as shown. Oh my god. On an iPad, doing bond enthalpy questions is a major pain because it's like all over the place. Because I only see like a tiny portion of the screen. You do as well, but oh well. When 1 mole of chlorine reacts with 1 mole of carbon, right, this equation is being explained to us. And I think they're just purposefully making this question harder. If they had just said delta H, whatever, it would have been pretty easy. And delta H is negative, by the way, because they're saying energy is released. So let's just make our lives easier. Put that in there. Negative 230. I'll skip the signs because it's pretty standard. Okay, use the information to calculate the energy of the bond between C and O in the carbon monoxide. The 3 marks, I think everything, thank God they're putting it together. Let's do that. Alright, enthalpy change of this reaction is everything broken minus everything formed. Everything before the arrow is broken, which is 1 chlorine-chlorine bond, and a carbon-oxygen from the carbon monoxide. I don't know what that bond looks like. It's not like that because carbon's bonds are incomplete. So it's a very interesting bond. What happens? We'll study that more in A levels. But we don't have to worry about it. We can just call it, or the value of it, X. That's done. Minus, because that's the one we have to find out. And formation. What's being formed is two carbon chlorine bonds plus one carbon oxygen bond. Pretty cool. Let's put in some values right here. Chlorine is 240 plus X, don't know that. This is minus 230, of course minus, and minus this entire thing. 2CCl is 800, I'll just put that directly. This value times 2 plus CO, which is 745. And the final value will very likely come out to, I think 1075. 1075. Let's move on now. Wow, this question doesn't want to end. Okay, this part is very easy because what they've done is they've shown this to you. They've shown this to you. What does this mean? It's a single bond. That means one chlorine, one carbon is bonded. So let's do that. One chlorine, two chlorine, one carbon, two carbon, and one oxygen, two oxygen. It's a double bond, right? One carbon, two carbon, one carbon. What am I missing? I just drew too many, I think. Okay. So let's finish it off. 1, 2, 1, 2, 1, 2, 1, 2. That's 6 for oxygen. Okay. 1, 2, 1, 2. 1, 2, 1, 2. 1, 2, 1, 2. 1, 2, 1, 2. 1, 2, 1, 2. Okay. I think we're done with the question finally. 17 marks. Not too bad. Let's move on to the next one. Iron is a transition metal element, right? Iron is a transition element. Potassium is a group 1 element. Iron and potassium have the same type of bonding. Name and describe the type of bonding in these two elements. It's metallic bonding. It is metallic bonding. It is a... Alright, it is... What is it? It is a lattice. I like the word lattice. It's just a fancy way of saying structure. Lattice of positive or cations, positive ions held together by a sea of electrons. Okay. Transition elements and group 1 elements have some similar physical properties. They can both be hammered into shape, conduct electricity, be stretched into wires. Name the term used to describe the ability of an element to be hammered into shape. This is just same questions over and over again. Not really too unique. Malleability. At this point I know the spelling. Describe what happens to the particles in iron. I think that's a subconscious Freudian hint for us to start doing paper 4s, sorry, ATPs as well. Describe what happens to the particles in iron when it is hammered into shape. So when you hit them, they realign, right? They slide over each other and the cloud realigns. So it's a 1 mark, so the ions slide over each other. H, although Just why copper rather than other transition elements is used for wires which conduct electricity? Because it is unreactive. All right, transition elements are harder and stronger. I know that. Describe how two other physical properties of transition elements are different from those of group 1 elements. They have higher densities, of course. What else? They have compounds. With, not with, form compounds, form colored compounds. That's what I meant. Let's erase that. Form colored compounds. Group 1 and group 2 elements, and they form solutions or salts, which are solid. They will be white, or the solution will be aqueous, or like, of course, but it'll be colorless, right? But transition elements will have color. You know this because if you look at the data booklet, you can see every transition element has a unique color. Copper is blue, iron 2 is green, iron 3 is red, so on and so forth. Let's move on. All right, chemical properties of some group 1 elements are shown in the table. Sodium, sodium, sodium. We need a flame test over here. For sodium, it is yellow. Potassium, it is lilac. And rubidium, I guess we don't know about rubidium, but we can predict its properties, right? Reacts with cold water. All right. So one thing is pretty clear. It'll have very strong effervescence. Very strongly effervescence. I don't think they're saying it right. Strongly effervesces. Okay, that makes sense. Strong effervescence, or very strong effervescence. I won't betray my roots. I won't say effervesce. And it'll also form colorless solution. All right. I'll take a gamble and try to say very quickly forms oxide layer. Okay, moving on. Name the gas produced when group 1 elements react with water. Group 1 elements reacting with water. Where's my hydrogen? Name the solution formed when potassium reacts with water. You have to name it, so potassium hydroxide. Hydroxide. Okay, moving on. Predict the pH of the colorless solution, like 13. 13. I would have gone with 14 as well. They're saying actually 7 to 14, anything is fine. Write the chemical equation for the reaction of sodium with oxygen. No problemo. Do we need state symbols? No, we don't. Sodium can react with oxygen to form Na2O. Needs a 2 over here, needs a 4 over here. I think we're good. Iron is the type of guy that typically reacts. Iron is a typical transition element. It is the catalyst used in the Haber process. Write the equation for the reaction that occurs in the Haber process. People would get confused and start writing an equation with iron. There shouldn't be one because it's a catalyst. N2 reacts with 3H2. I don't think we need state symbols over here again. Didn't specify. 2NH3. Okay. State the temperature and pressure used in the Haber process. Haber. Temperature is 450 degrees Celsius. Temperature is 200 atmospheres. Write the general formula of alcohols. It is CnH2n plus 1 OH. Explain why ethanol cannot be described as a hydrocarbon. It has oxygen. Lol. Ethanol can be manufactured from different substances by reaction with steam or by fermentation. Give the formula of the substance which reacts with steam to form ethanol. Well, I don't know why I was thinking about it so much. They're talking about ethene can react with steam, water, to form ethanol. What kind of reaction is it? Addition. I'm surprised they're not talking about the conditions further on. Maybe they will in the next part. Name the substance which will react with this to form ethanol. Glucose in fermentation. Write the chemical equation for the complete combustion of ethanol. Okay, let's do that. Ethanol is C2H5OH plus O2. Carbon dioxide plus H2O. And see if we can just directly balance it. 2 over here, 3 over here. That's a total of 3 oxygens coming over here and 4 oxygens over here. I already have 1, so I need 6 over here. So if I put a 3 over here, I will get 6 indeed. Everything else is more or less balanced out. Pretty good, pretty good, pretty good. Let us move on. One molecule of ethane 1,2-diol. It's a diol because it has 2 OHs, 1 toward the position because it's on the first carbon and the second carbon. You may ask which one's the first carbon, which one's the second carbon. I'm going to tell you, does it really matter? Ethane 1,2-diol will react with 2 molecules of ethanoic acid to form molecule X. X has 2 ester functional groups, and the molecular formula is this. State the empirical formula of this. I think if we just divide these values by 2, we'll get it. So it's going to be C3. What is it? H5O2. Can't get any more simplified than that. Let's move on. Draw the structure. That's disappointing. But easy. Okay, this is... I'm not drawing the hydrogens. This is the molecule above. Of course, it has 4 hydrogens, which I'm not drawing. The alcohol is known to lose the hydrogen, and it has lost the hydrogen. Now it's going to react with ethanoic acid. So what's that going to look like? Ethanoic acid. one here, one here. Now to just decorate it with hydrogens. Mm-hmm. 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 Now, if I were you, I'd probably mess up one of the hydrogens. So I would say double count. Or you have to actually have the formula on top so you can count and make sure it's the correct one. Number. So I have 3, 4, 5, 6, 7, 8, 9, 10. I think I'm pretty happy with this molecule. Name the other substances formed in this reaction. Oh my, oh my, oh my. Dihydrogen monoxide. Each alcohol function group in ethane 1,2-diol reacts with acidified potassium manganate. Name the function group that is formed. Each alcohol function group is reacts. Name the function group. It's a carboxylic acid function group that forms carboxylic acid function group. Pretty cool. Draw the structure now. Okay, kind of intensive on the whole organic front, ain't it? Okay, let's actually draw the molecule again just for our understanding. Now, what's going to happen is this is an alcohol function group, and ignore the hydrogens. If you have an OH, that'll turn into an acid, that function group. So over here, I'll have to add these new things like that. And if I look closely, I don't think I can put any more hydrogens in there. So I'm left with no hydrogens. And ethane 1,2-diol will turn into ethane 1,2-dioic acid. And this is it. Pretty cool. And this is the end of our paper. Pretty easy. I think we did it very fast this time. All right. See you guys in the next one.